Let's begin. Today is October 16th, 2024, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses the following 6 criteria cards. Criteria card 6, 11, 16, 19, 21, and 22. And the puzzle uses the blue verification cards. The code above is your way to get more information on today's puzzle by searching the code on turingmachine.info. Let's go solve. So in the grid above, we've got our 6 criteria cards. On the top row, we've got criteria card A, criteria card B, and criteria card C. On the bottom row, we've got criteria card D, criteria card E, and finally, criteria card F. Criteria card A takes a look at our middle digit, the square digit, and the Turing machine will let us know whether that's an even digit or an odd digit. Criteria card B takes a look at our first 2 digits, triangle and square, and compares them. So should the value of triangle be less than square? Should they be equal, or should the value of triangle be greater than square? Criteria card C will take a look at our 3-digit solution and will let us know a little bit about the ratio of even to odds. Should there be more even than odds, or should there be less even than odds? Criteria card D again takes a look at our first 2 digits, triangle and square, but this time it'll add them together and compare that sum to the number 6. So should the sum be less than 6? Should it be equal to 6? Or should the sum be greater than 6? Criteria card E again takes a look at our 3-digit solution, but this time it'll let us know a little bit about its structure, so to speak. And there are 2 cases, one where there is a pair in the 3-digit solution, as in the example 131, or alternatively, there are no pairs. But there are 2 cases, one where all the digits are distinct, as in the example 134, or all the digits are the same, as in the example 222. And finally, criteria card F again takes a look at our 3-digit solution, from triangle to square to circle, and will let us know a little bit about the ordering of the digits. Should the digits appear in an ascending order, meaning that they're increasing, as in the example 135, or should they be in a descending order, or decreasing, as in the example 421, or finally, could the 3-digit code have no order? So let's take a look at the example 231. Notice that it goes from 2 to 3, it increases, and then goes from 3 to 1, and then decreases. So it's that shift from increasing to decreasing, or in other cases, decreasing then increasing. But it's that shift that is one way to define a 3-digit code to have no order. We've also seen other puzzles in the past where if you have consecutive equal digits, meaning 2 digits that are equal to each other next to each other, that also exhibits no order because, like, let's see, do we have an example? I don't see an example up here, but I can offer you one as in 225. So there's no change from 2 to 2. So the absence of change also is another way to define a 3-digit code to have no order. And remember, the objective of today's puzzle is to find that unique 3-digit code that abides by all of the 6 criteria cards we just discussed. And we're going to start off with an initial proposal of 314. So the first thing I like to test is criteria card A. Okay, so the Turing machine does not approve of my choice for square. I did choose an odd 1, but the fact that the Turing machine does not approve of that lets us know that square should be an even digit. So let's go ahead and type that up in our notes in section A. And we'll say that square is an even digit. And since we know it's even, well, let's go ahead and cross out the 3 odds. So crossing out 1, 3, and 5. Okay, the next thing I think I'd like to test is criteria card C. Okay, so the Turing machine does approve of my proposal. Notice that we are counting even versus odds. So in my proposal, I've got 2 odds to a single even. So that means that, yeah, there should be more, or I should say there should be less even than odds. And that again is in criteria card C. So let's go ahead and type that up. So we'll say that there should be less even than odds. And notice that we already determined that square is even. So that means that we do have a single even in our solution, but that means that triangle and circle must be odd, since we've already established that there should be a majority of odds. So let's go ahead and cross out the evens in both triangle and circle. And so basically we're looking at a solution that is odd, even, odd. Okay, so what else? Well, we do have this criteria card D that adds up the first two digits. Now that we know we have an odd and an even, we know the sum cannot be equal to 6. So that means that it's a 50-50 whether it's less than 6 or greater than 6. And we do have 2 odds. Just curious if maybe they're paired up. Let's see. Yeah, let's go ahead and test criteria card E. Okay, so the Turing Machine does approve of my proposal. Notice that in 314, they are all distinct, meaning that there are no pairs. So let's type that up in our notes in section E, and we'll state it as that the solution has no pairs. Okay, and of course of the 2 scenarios, it can't be a single digit repeated 3 times, since we do have odds and evens. So obviously they're going to be all distinct. Okay, well, I think that does it for this round. We really couldn't cross out anything else, but that's okay. We're going on into the second round, and we're going to discuss how to construct a good second round proposal. So notice we did not test criteria card B, comparing the first 2 digits. Obviously, again, we have an odd and an odd in triangle, even in square. And we did not test criteria card D, the sum of the first 2 digits. And of course, we have criteria card F that lets us know the ordering of the digits from triangle to square to circle. I believe, having played few puzzles, we may be able to deduce what F will eventually reveal. And that is, I believe the logic is, if you assume that the ordering is ascending, meaning it's increasing, it's obvious that criteria card B would be irrelevant, because yes, it would be true if it were ascending. That triangle would be smaller than square, because they would be in an increasing order. So that would make, criteria card B irrelevant. And similarly, if it were in a descending order, we would establish that triangle would be greater than square. So in descending, triangle would be greater than square, again making criteria card B irrelevant. So I think in general, in this case where we have this type of criteria card B comparing the first 2 digits and the ordering criteria card F, we've established that we could deduce that the solution should have no order. Okay, so that frees up at least one criteria card to test. But everything from round one is well established. We did get our 2 check marks, and the lone X just made us or informed us that square should be an even digit. So we'll make sure to have a proposal that has square as even. Okay, so so it really boils down to B and D, the sum of the first 2 digits. So we are dealing with no order. So let's see. Could we have a triangle value of 5? I don't think triangle could be 5, because then I guess everything would be smaller. Triangle would be the greatest value, perhaps. Is that logical? And for the same reason, I guess triangle could not be a 1 for the other alternative, which is that triangle would be smaller than all of the square values. So perhaps triangle's going to be a 3. And so if it's 3, it could be either 3 to 5 or 3, 4, 1. Let's go with 3, 4, 1 and just see where that takes us. Okay, so I guess let's go ahead and test criteria card D. Okay, so it's not the case that the sum of the first 2 digits is greater than 6. As I mentioned at the top of this second round, the sum cannot be equal to 6 because we are dealing with odds and evens. That when you add an odd and an even, that's always going to result in an odd value. So that means that we could deduce that the sum of the first 2 digits must actually be less than 6. So let's go ahead and type that up in our notes, and we'll say that we're going to, oops, that's in D. We're going to deduce that triangle plus square should be less than 6. And what can we say about that? Well, if the sum of the first 2 digits must be less than 6, then we can actually cross out the 5 in triangle. And the reason for that is if you add 5 even to the smallest of a 1, that would already give you a sum equal to 6, and anything bigger than 1 would just exceed that. So yeah, we can cross that out. And so now, can we somehow deduce let's see. So it may be, can we deduce that square should be 2? Because if square were 4, well, obviously as it looks, yeah, 4 is bigger than both 1 and 3, but I'm not sure if getting this deep into, canceling numbers, if that's in general a good logical argument. Let's see. But as far as, oh, well, of course, oh, wait. Well, it certainly couldn't be 3, 4. Let's put it that way. It could be 1, 4. And let's see, if square were 2, well, it would work for both, but we do have this criteria card that would order them. So let's see, could we are dealing with a no order. Yeah, I guess. Let's see. Well, let's go ahead and test criteria card B. Okay, so it is true when we're comparing triangle and square. Since my value for triangle is 3 and my square value is 4, yes, triangle 3 is less than 4, so it's true that triangle should be less than square. So let's go ahead and type that up, and then we'll see what we can cancel. So triangle should be less than square. Okay, so let's see. I don't know if that really revealed that much. Yeah. I mean, both cases still, well, let's see. Yeah, I think you can cross out 3. So if we cross out 3, yes, it's less than 4, but you wouldn't pick it because 3 and 4 exceed 6. And yeah, and then 3, 2 wouldn't work because then triangle would be greater. So yeah, so I think we can cross out the 3. Okay. And so I don't think it could be a 2 because then you would be, let's see. Yeah, you would be forced to pick either 3 or 5, but all those lead to an ascending order of digits. And there's nothing really to help us choose between 3 and 5. So yeah, I don't think it's going to be a 2. And so now that we have 1, 4, again, because of the no order, well, 1 would fail because you'd have a duplicate and we can't have pairs. And 5 would fail because that would be also an ascending solution. So yeah, it looks like it should be 1, 4, 3. So let's go ahead and cross out the 1 and cross out the 5. And it looks like our solution should be, again, 1, 4, 3. So let's type that up. Okay, and let's review if everything meets all the criteria. All right, so is that middle digit even? Yes, it's a 4. Is the first digit smaller than the second digit? Yeah, 1 is less than 4. There are more odds, 1 and 3 versus the lone 4. The sum of the first 2 digits, is it less than 6? Yeah, 1 plus 4 is 5. That's less than 6. There are no pairs. And again, we deduced that the solution should have no order, and it does not have. It has no order. Okay, well, let's go verify that our solution is 1, 4, 3. Fantastic. And how do we do versus the Turing machine? Well, as I recall, I think we only did 5 tests versus the 6 criteria cards. So that was very helpful. And so let's see, we did ACE in the first round, and then we did BD in the second. So let's go ahead and type that up, and we skipped F. So A, C, E. So A was wrong. C and E were correct. I believe B was correct, but D was incorrect, and we deduced F. So, wow, okay. So we beat the Turing Machine by one question. I was really expecting maybe two, just because we did deduce criteria card F outright. But overall, I think it was a great puzzle. Always kind of challenging us. I didn't mention this, but I normally do. You notice that there were no references to circle. So yeah, it was basically the ordering, I think primarily the ordering criteria card that really settled what circle should be to 3. So it basically forced us to choose the 3 for circle. So how did you solve it? Did you choose a different order or a different set of criteria cards in round 1? And did you see anything interesting that you'd like to share? Well, write those up in the comments. If you liked the video, please do give it a thumbs up so that more people can find the channel. And of course, if you don't want to miss out on any future videos, hit subscribe to be notified. Well, until next time, have a great one.